A very good day to Dr. Bajan. I'm Divya here with student ID 201406. Today, I would like to present my e-portfolio for physical chemistry, which have a course code of CEB1023. First and foremost, this is the contents of this e-portfolio. Now, I would like to share vision and mission of UTP. First, as written there, that is the one vision, and the second one is the mission. Now, I would like to introduce the program educational objective of Chemical Engineering Department. Firstly, engineers who are competent with potential to become leaders in chemical process and related industries. The second one is engineers who are committed to sustainable development of chemical process and related industries for the betterment. Now, I would like to introduce to the program outcomes. In addition, this is the course learning outcome of this semester. Firstly, CLO1, the understanding the principle and theoretical aspect of ideal gas, first and second law of thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical system. Secondly, CLO2, analyze the complex problems of first and second law of thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical system. Finally, the last yellow of this semester, design and analyze the lab experiment for thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical system. Furthermore, I would like to share the chapters of this semester. Chapter 1 is Introduction to Thermodynamics. Chapter 2 is the first and second law of thermodynamics. Chapter 3 is Phase and Solution. Chapter 4 is Chemical Kinetics. Chapter 5 is Catalysis, and last but not least, Chapter 6 is Electrochemical System. Now I'm gonna explain table of content of each chapter. This is the table of content of Chapter 1, Chapter 2, and Chapter 3. This is the table of content of Chapter 4, Chapter 5, and Chapter 6. In addition, now I would like to share questions and answers for quiz 1 that I had during this semester. Next, this is the questions and answers for quiz 2. Furthermore, this is the questions I had for test 1, which I managed to snap during the test 1. This is the answers for the question 1. This is the answers for question 2 and question 3. So this is the questions I had during test 2 because of my student ID ending with 6. Now I would like to present the question 1 answers. This one is the question 1 answers, and this one is the answers for question 2 and question 3. In addition, now I'm going to explain about distillation plant process, which involved by Raoult's law and Dalton's law. Raoult's law states that the solvent's partial vapor pressure in a solution or mixture is equal or identical to the vapor pressure of the pure solvent multiplied by its mole fraction in the solution. Mathematically, Raoult's law equation is written as in the slide I given. For an example, consider a solution of a volatile liquid A and B in a container. Because A and B are both volatile, there would be a both particle A and B in the vapor phase. Hence, the vapor particles of both A and B exert partial pressure, which contributes to the total pressure above the solution. Now, I would like to explain about Dalton's law. Dalton's law refers to the total pressure of a mixture of gas is equal to the sum of the partial pressure of the individual component gases. The partial pressure is the pressure of each gas would exert if it alone occupied the volume of the mixture at the same temperature, as given there. That is the Dalton's equation. The combination of Raoult's and Dalton's law describes the vapor pressure produced by a miscible two-component system, which is component A plus B. This combined law shows that the vapor pressure produced by distillation are dependent on each component's vapor pressure and quantity, which is mole fraction. So P solution equals to P naught A x A plus P naught B x B. A compound's vapor pressure reflects the temperature of the solution well as the compound's boiling point. As the temperature increases, a great percentage of molecules have sufficient energy to overcome the IMF force and holding up them in a liquid phase. Therefore, compound's vapor pressure always increases with temperature. Now I'm going to further explain on distillation plant process. Basically, distillation is the process of separating the components or substance from a liquid mixture by using selective boiling and condensation. Distillation may result in essentially complete separation, nearly pure components, or it may be partial separation that increase the concentration of selected components in the mixture. In either case, the process exploits differences in the volatility of the mixture components. Distillation has many applications. For an example, distillation of fermented products produces distilled beverages with high alcohol content. Other than that, in the fossil fuel industry, oil stabilization is a form of partial distillation. Moreover, in cryogenic distillation leads to the separation of air into its component. Furthermore, water distillation also produces clean, pure water, which we will consume it. Now I'm going to further explain about distillation plant process by picking an example of distillation plant process, which is water distillation plant process. As we know, water distillation plant process is a crucial for our daily life as water is important to live a healthy lifestyle. Water distillation plant process. The distillation process is as follows. Water is heated in a boiling chamber first, then the water is heated to a rolling boil which causes evaporation and steam production. Secondly, the steam leaves the boiling chamber. The steam from the boiling water rises through a vent into stainless steel condenser. Any microorganism, impurities and contaminants that are unable to convert into a gas particle are left behind the boiling chamber. Thirdly, steam condensers. Once steam reaches the condenser, it is chilled by a fan until it turns back to the water droplet. Therefore, this is the place where Rawls' law and Dalton's law plays a fundamental role. These droplets now ready to be collected in a clean container, but there is one final filtration stage first. Finally, remaining contaminants are removed. Any impurities that have evaporated and condensed with the water can now be removed. Usually, an activated carbon filter will trap these contaminants using the process of adsorption. Water collects in the storage container. After passing through the filtration media, water will drip out of the distiller's spout and into a holding container. This water is now clean, pure, ready for use. Distillation can remove a broad range of contaminants from water, including nitrate, iron, lead, hardness, and some microorganisms. The overall effectiveness of distillation depends on the contaminants the water contains. Finally, we are reaching to the end of this e-portfolio. Hence, I would like to share how I met the learning outcomes. I would proudly say that I've accomplished the learning outcomes throughout this semester by the guidance and teaching of Dr. Bhajan. Basically, I've attended all the lecture classes as well as tutorial classes and extra classes prepared by our UTP lectures. By doing so, I have achieved CLO1, where I got a clear understanding in the principles and theoretical aspect of ideal gas, first and second law of thermodynamics, phase behavior, reaction kinetics, catalysis, electrochemical systems. For instance, from doing the tutorial exercises, I am able to differentiate intensive and extensive properties and perform calculation using ideal gas equation for partial pressures, mole fraction, amount of gases, and gas density from chapter 1. Besides, in CL2, I have learned to analyze and solve many complex problems such as performing calculation in CLO2. I have learned to analyze and solve many complex problems such as performing calculation using first and second law of thermodynamics, calculating properties in thermochemistry, calculating phase transformation and equilibria, and the calculation involved in adsorption. Although I came across many difficulties in the calculation, I overcame the problem by the guidance of the lecturer, doing a lot of practice during tutorial and watching the videos sent by Dr. Bhajan in our class WhatsApp group. As a result, I able to complete all the questions very easily. Last but not least, according to CLO3, I'm eagerly looking forward to attend my laboratory session after my extended assignment as it is postponed due to COVID-19. Based on CLO3, we have to design and analyze an experiment for thermodynamic, phase behavior, reaction kinetics, and catalysis plus electrochemistry system. Therefore, I hope that I can give my best to CLO3 to accomplish with good lab marks. Thank you. Thank you, sir, for listening my e-portfolio project.